So when we talk about a circuit, circuits do not exist without some form of power that is feeding electrical current to that circuit. Okay, you can't make electrical current out of nothing. Okay, so when we're talking about that power supply, we're talking about the actual, and I'm going to draw the switch here closed. Here's my light bulb. Okay, this power supply here is giving off electrons. Okay, it is what is fueling the actual loop, or the electrons to move around that loop. They leave the power supply, okay, and they go all the way through. They actually react with whatever the resistor is, and they close the loop. Now, they don't go back to the power supply. Remember, that energy gets transferred from electrical to, in this case, radiant, right? So, when we talk about power supplies, there's usually 3 different types, okay? 2 of which you are very, very, you're very knowledgeable about and comfortable with. The first one is a battery. Okay, so you've got your positive end here, and your negative end down here, your flat end. Okay? Just like when we have our power supplies, we've got our positive and our negative, right? Now, the interesting thing about a battery, inside a battery, most of these are actually, a lot of them have lithium inside them, okay? And what ends up happening is inside a battery, we have a lot of chemicals that are breaking down and reacting with one another. And as those chemicals react, they give off excess electrons. Okay, so basically, batteries are a chemical source of energy. So if they ask you a question and something is battery packed and they want to know what the energy transformation is here, we usually go from chemical to whatever else is being caused. So if it's a battery that's making a light up, then it goes chemical to, what is light energy? Radiant. Chemical to radiant. If it's, in the case of the dog ball launcher, the ball lands on the switch, turns the circuit on, an arm actually starts being moved like so, and there's a spring attached to it that when it gets to its max, then the spring does the rest and it swings back. So if that actual battery makes the arm move, what type of energy is that? Kinetic. Okay? If the battery is linked to a bell and it makes a sound go off every time the circuit is on, acoustic. So when we're talking about batteries, it's a chemical form of energy. When we're talking about actual plugs in the wall, okay, these plugs here, where normally you've got 1, 2, and you've got that circular one. Okay, you've got the 2 straight prongs and the circular prong. An electrical outlet works the exact same way. You'll often notice that when you plug something in, have you ever tried to plug something in a circuit and in a wall outlet and it didn't fit and you had to turn the plug around and then it fits? Yeah. Well, that's because your actual plug has a positive end and a negative end. Okay? And it will not actually work. It won't fit if it moves, if it's plugged into the other end, if it's plugged opposite. The bigger of the 2 won't actually fit into the smaller one. Now that third one, this guy right here, whether it's there or not, that's usually called the ground. Okay? And whether it's there or not has no difference. It makes no actual difference as to whether or not the circuit works. It is called a ground because it helps stabilize the plug. Okay, so case in point, a kettle of mine at home, yanked it out of the socket, wasn't paying attention. Next thing you know, that part, this guy right here, stayed in the actual socket. So I had to turn the breaker off, take pliers, because you never put electrical Like you never put metal stuff in a socket, and I had to pull it out. Okay, but my kettle still only has those 2 plugs at the top, and it works just fine. Okay, and it's no more dangerous or anything. Okay? Just like the battery is always, or any type of battery is always chemical, plugs are always electrical to whatever. So if I was plugging in, something and it gave off light, then it's going electrical to radiant. Or if I was plugging in something and it gave off sound, electrical to acoustic. Okay? So in terms of an actual electrical outlet, it's always electricity that's the initiating energy or the input energy. Okay? And the final one is something called a photovoltaic cell. Photovoltaic cells, it's just a fancy name for a solar cell. And what solar cells do is they basically create electricity based on capturing, radiant energy from the sun. And those solar panels are actually geared to convert however much sun and the strength of the sun it's getting into certain amounts of electricity. Okay? So if you've got something that's solar powered, like I've got lights up here that are solar powered. So these little kind of Christmas lights sort of things that they don't have a plug. You can't plug them into the wall. You've got to basically let the battery pack charge up via, solar energy. And what it will do is it will transfer that to electrical energy. And then those electrons will then go through and then get transferred again into something else. So on page 463, it breaks down all 3 of these different types of power supply, and it talks about advantages and disadvantages of them. It's worth a read.